Hello class. Today we're going to cover section 3.4, Trigonometric Identities. So first we'll talk about the quotient identities. And so tangent theta is equal to sine theta over cosine theta. That's one of them. And cotangent theta is equal to cosine theta over sine theta. You can see they're reciprocals of each other like they're supposed to be. Some of the reciprocal identities: cosecant theta is equal to 1 over sine theta. Secant theta is equal to 1 over cosine theta. And cotangent of theta is equal to 1 over tangent theta. There's also some Pythagorean identities that are useful. Sine squared theta plus cosine squared theta is equal to 1. Tangent squared theta plus 1 is equal to secant squared theta. And cotangent squared theta plus 1 is equal to cosecant squared theta. Those are the three Pythagorean identities. And then odd and even functions. Sine of negative theta is equal to negative sine theta. That's an odd function. Tangent of negative theta is equal to negative tangent theta. That's another odd function. And cosecant of negative theta is equal to negative cosecant of theta. Those are the odd. The evens are cosine of negative theta is equal to cosine of theta. Secant of negative theta is equal to secant of theta. Oh, and I forgot one more odd one. My apologies. Cotangent of negative theta is also equal to negative cotangent of theta. So these are, the purple are the odd, and the non-highlighted ones are the evens. Okay, so we're going to be using this information to solve a few problems. Here's the first example. So in order to show that this identity is true, I'm only going to be working with this side and making it look like the other side. So what I'm going to do is I'm going to go cosine of theta over 1 plus sine theta. And what I'm going to do is I'm going to multiply both sides by the conjugate of the denominator. And so that's going to give me cosine of theta times 1 minus sine theta. And on the denominator, I'm going to get 1 minus sine squared theta because they're difference of squares. And I'm going to get cosine of theta times 1 minus sine theta. And we see that the denominator is one of the Pythagorean identities, a manipulation of it actually. And so that's cosine squared theta. Just in case you don't see that, I'll do that on the side. Remember, it was sine squared theta plus cosine squared theta was equal to 1. So then cosine squared theta is equal to 1 minus sine squared theta. And that's how I did that. Now canceling from there, I'm going to get 1 minus sine of theta over cosine of theta. And we can see that that is in fact the other side. And so we've done this problem and solved it. This is kind of what you're going to be doing in this section for the homework. Right, with this problem here, I'm going to use the rules that we know. So sine of negative theta squared plus cosine of negative theta, that whole quantity squared, is equal to 1. Well, that's what we're trying to show. So I'm going to, again, only be working with this side. So the identity tells me this is an odd function. So it's going to be negative sine theta squared plus, this will become cosine theta squared. When I square both, then the negative will drop, and I get cosine squared plus, or sine squared plus cosine squared, which we know is in fact 1. And so we've solved that problem. Okay, our next example of an identity, and again, I will be working with this side to show that it is the other side. Again, demonstrating, I'm going to go negative sine of theta squared minus cosine theta squared, that's going to be the numerator, over the denominator is going to be negative sine of theta minus cosine of theta. And again, that's using the odd and even function definitions. I see that I'm going to get in the numerator sine squared theta minus cosine squared theta, and then in the denominator I'm going to factor out a negative, so I'm going to get sine theta plus cosine theta. And then since the numerator is a difference of squares, I know that I can write that as sine of theta minus cosine of theta times sine of theta plus cosine of theta over negative sine of theta plus cosine of theta. And we can see here, we can cancel some things. So this is going to cancel with this. And I'm going to get sine of theta minus cosine of theta all over negative 1. But that just changes the signs up above. So I'm going to get negative sine of theta plus cosine of theta. And we can see I can rewrite it so it matches exactly what the other side is. Cosine of theta minus sine of theta. And once again, I've shown that this is, in fact, true. All right. Our next example is to show this. And so I'm going to use, again, the left side to work this out. And so I'm going to rewrite it as 1 plus tangent of u over 1 plus 1 over tangent of u. And then from there, I can clean that up by making common denominators. So I'm going to get 1 plus tangent of u. And then in the denominator, I'm going to get tangent of u plus 1 all over a tangent of u. I'll make this one bigger just so you guys can tell. The only changes I really made here was going from, I changed the denominator. Now we know that when we divide by a fraction, we multiply by the reciprocal. So I'm going to get 1 plus tangent of u times tangent of u over and tangent of u plus 1. And we can see that this is the same as this. And so we see what we end up with is tangent of u, which is what we wanted to show. A little bit of the algebra here is tricky, but it's manageable. If you need some help or some tips on how to do those, by all means contact me and I will help you. Okay, this is a fun problem. This is going to be a little bit of work, but that's okay. So what we're going to do is I'm going to make common denominators. And since I'm making common denominators, I'm going to multiply each by the other's denominator to the numerator. And that allows me to write it like this. So what I did is I ended up multiplying sine with sine and multiplying 1 plus cosine theta with 1 plus cosine theta, which then gave me the numerator, and then the denominator was just the two denominators being multiplied together. Okay, so once we do this, we see that this is going to be sine squared plus 1 plus cosine theta squared over my 1 plus cosine theta times sine theta. Now I can expand the numerator, so that's what I'm going to do. I'm going to go sine squared theta plus 1 plus 2 cosine theta plus cosine squared theta and again rewriting my denominator. With these problems, you'll notice that it's easy to make mistakes, so be very, very, very careful when doing these. Now I'm going to rewrite this in an order that allows me to see what I'm trying to do. So I'm going to go 1 plus sine squared theta plus cosine squared theta plus 2 cosine theta all over the denominator, which is 1 plus cosine theta times sine theta. And what you'll see that I'm doing here is I see that this highlighted piece is 1. So I'm going to go 1 plus 1 plus 2 cosine theta all over my denominator. And what this is going to allow me to do is now I can factor out a 2, right? So I'm going to get 2 plus 2 cosine theta over this denominator. I don't want to cut shortcut steps so you guys can see it all. I'm trying to be as helpful as I can. So then I'm going to get a 2 out, and I'm going to get 1 plus cosine theta over 1 plus cosine theta times sine theta. And what we see here is that this will cancel with this, and that's going to give me 2 over sine theta, but 1 over sine theta is cosecant. And so I'm going to get 2 cosecant theta, and I believe, yep, that is the same as that. All right. Let me do 2 more examples for you. Here's the next one. And sometimes when you see tangent and cotangent and secant, cosecant, it may be easier to convert it to sine and cosine, and so I'm going to work with the left-hand side, and I'm going to convert it to sines and cosines. So I'm going to get sine of v over cosine of v plus cosine of v over sine of v. That's the numerator piece. And then 1 over cosine of v times 1 over sine of v. And let's see what we can do here. So what I'm going to do is I'm going to make a common denominator, and I'm going to get sine of v squared plus cosine of v squared over cosine of v times sine of v. And in the denominator, I'm going to get 1 over cosine of v times sine of v. And again, we know that when we divide by a fraction, we multiply by the reciprocal. So I'm going to get sine squared of v plus cosine squared of v over cosine of v sine of v times cosine of v sine of v over 1. And we notice that this cancels with this, and what we're left with is sine squared of v plus cosine squared of v all over 1, which we see that numerator should look familiar. That gives us 1. Obviously, these are going to take a little bit of practice, but knowing your identities and having those sheets with you to look at and reference will be beneficial. It should be very, very good for you. All right, let me do this last example for you, and we'll go from then I'll let you guys get to some work. So I'm going to work on the left-hand side, and so what I'm going to do is I'm going to multiply both the numerator and denominator by the conjugate of the numerator. And so what that's going to give me is 1 minus sine squared theta over cosine theta times 1 plus sine theta. Then from here, I know that the numerator is an identity, so I'm going to get cosine squared theta over cosine theta times 1 plus sine theta. The cosines will be able to cancel, so I'll be left with 1 cosine in the numerator over 1 plus sine theta in the denominator. And look at that, we've gotten our answer. As always, please leave a comment or a question in the section, and I'll answer you or post it on the discussion board on Canvas. As always, all the best.